Hello, I'm Fred Jason. I'm the product manager for the PowerFlex 7000 medium voltage family of drives. We also have a PowerFlex 6000 product line that is targeted towards general purpose applications such as fans, pumps, and compressors. I'm going to talk about today what we call our special purpose drive, the PowerFlex 7000, that's really targeted towards cranes and hoists, downhill conveyor applications, any applications that require either regen braking or regenerative operation, or potentially holding torque at zero speed, and also extremely long motor cable lengths because of this specific topology and the benefits that it offers. So a couple of things that I just want to focus on. Just as an overview, the PowerFlex 7000 is available from 2300 volts to 6600 volts, from essentially zero all the way up to 720 amps. We offer 3 different frame sizes, an A, B, and C, and all that means is an A-frame is optimized for small size and lower power air-cooled versions. Then we have a B-frame that goes in higher power versions, and then we have a C-frame or liquid-cooled for marine applications and a wide variety of applications where customers potentially want to reject a lot of the heat out of the particular control room to reduce air conditioning costs. And in addition to that, again, keeping our product line as flexible as possible, we offer a variety of configurations as well. We have an 18-pulse transformer version that's really targeted to high-power constant torque applications. We have options for indoor and outdoor separate transformers. We have an option for an integral transformer. And then most of our products, our product sales are around the direct-to-drive configuration that we're showing here in this example. And the reason it's so popular, it's a transformerless configuration. So it means the customer can bring in their cables from the utility, connect to the drive, 3 cables in, 3 cables out to the motor. So it's very small, it's very compact, it's extremely high efficiency because it doesn't have the efficiency loss of an isolation transformer in front of it. So this configuration is an A-frame, direct to drive. It has an integral transformer, that's an option, but the nice thing is then you've got your branch circuit and disconnect all in one package. Instead of the isolation transformer, you've got a very small line reactor in the bottom of this cabinet. Essentially, the center section is the inverter along the top 3 modules, the rectifier along the bottom 3 modules, and then the far cabinet, we've got a common mode choke that allows you, again, to operate standard motors. You don't need a special inverter duty rated motor because of the common mode choke. Again, 3 cables in, 3 cables out. Just 2 things I really wanted to focus on. It's really the devices themselves and what it gives you as a benefit. So first of all, just to recap, getting rid of the transformer on the front end means a very high efficiency drive reduces your operating costs. Higher efficiency, the lower your operating costs. So that's kind of the first thing I wanted to point out. And the second part is really around the topology and the fact that it has what we call an SGCT as a switching device. That refers to symmetrical gate commutated thyristor. So why is that important? There's a couple of benefits you get with an SGCT. So here's the devices. So bottom 3, what we call power cages, these red housings, we call them power cages, and all the devices in one phase fits in one of these power cages. So this is phase A, B, and C of the rectifier, A, B, and C of the inverter. So a single bridge. So you don't have multiple bridges, you don't have a lot of components. It's the lowest component count of any drive topology in the marketplace. Lower component count, higher reliability per component means an extremely reliable package. So many or most of our customers are extremely concerned with uptime. And with a low component count and each component with very high reliability delivers that maximum uptime that most of our customers are looking for. When you look at the SGCTs, a couple of real advantages with an SGCT. It's symmetrical. That means it can conduct power to the motor from the utility grid and from the motor back to the utility grid. So if you require applications that need regen braking, it's built in. If you've got applications such as downhill conveyors that are operating in a regen mode all the time, this provides that 4-quadrant operation without any additional hardware, without any additional cost. The other big benefit with the SGCT is it's got very low dV/dt rise time. So if you think of low voltage drives, a lot of times their distance between the drive and the motor is very limited because of high rise times of the devices. This device features a 50 volt per microsecond rise time, which is exceedingly low in the marketplace. We operate these drives with motors up to 30 kilometers away from the drive, and we've got many applications up to that rating. Very popular for electrosubmersible pump applications, for subsea applications, or any applications especially for mining, long overland conveyors. This provides you a tremendous amount of flexibility where you deploy the equipment to make it more cost effective from a system solution perspective. So I know there's lots of features and benefits we can talk about, but I really wanted to focus on these couple to give you some perspective about the technology that goes into it, how user-friendly it is, and how great it is for a wide variety of these special purpose applications we address with the PowerFlex 7000. So, if you want any more additional information, please contact your local Rockwell Automation representative. Thanks for watching. Have a great day.